All right, in this video I want to talk about some other things that we can do with negation. So we talked about some translation aspects with prefixes and suffixes. We talked about unless. Now I want to say, what can we do with negations? What are some rules that we have to introduce for negations? Now, first thing I want to say before I even get to that part is how the stuff with negation simply overlays stuff that we've already done with, say, modus ponens and adjunction and conjunctive elimination. So like arrow out, and in. That now, so if we had something like this, not A, arrow, not B. We got not A. What can we get? Now, I don't want it to be a mystery for you. This is not something really new here. With or without negations, the old principles that we've had still stick here. So, do we have an arrow? Yes. Do we have a match? Do we have a match to the left side? What's the left side? The left side is not A. Do we have a match? Yes. Not A. What does that mean? We can get the right side. The right side is not B. The right side is not B. How do we do this? Some new thing? No. Arrow out, 1 and 2. Or if we had not A and B separately and in, we can simply put them together. Not A and B. Okay, and in 1 and 2. Similarly, if we started with not A and B, we could break those things apart. Not A and B. And out line 1 for both in this case. This is simply to say that make sure you keep track of negations now when we're incorporating these, and it doesn't change any of this old stuff that we've been doing with the arrow outs, and ins. You just need to make sure that you're keep in mind when negation is in play. That being said, we do have some new things that we can do with negations. The main thing I want to talk about here is the notion, the rule of double negation. Now this is in formal logic. I want to make sure that's clear. Double negation works basically this way, and that it's a move which allows you, basically, if you have an even number of negations present, you can say it's the same thing as having no negations. And if you have an odd number of negations, it's the same thing as having only one, and vice versa. So what that means is something like this. If I said, not A. So this is an even number. You could say they cancel each other out. What's the same thing as saying? The same thing as saying A. How do I get that? Well, if we have this assumption, we can say, okay, double negation, line 1. Now, this is not a rule of inference. This is a rule of substitution. What that means is that it can work the other way as well. Can't do it without modus ponens. We can't start with B and then go, oh, A arrow B, also A. Doesn't work that way because that's a rule of inference. It's something that involves deduction. This is a deduction as well, but it's not an inference, it's a substitution. What I mean by that is a rule of substitution is something where you're saying this and this are basically the same thing. We're just doing a little bit of switching there. And in my estimation, this is well formed and this is not. Okay, because well formed meaning the simplest way that we can write something. Just like you could say, if I said write the number 10 on the board, and you went, 1 plus 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 1. There, I wrote 10 on the board. Did you do that? Sure, but you could have done, this instead. And I would have preferred that. So is this correct? Yeah. Is it well formed? No. So we want to make sure when we're making our statements, we probably want to be as simple and as well formed as possible. Not that it's bad. We can get this from this, but we can also get this from this. Now there might be times when you actually want to do this with negations. So for example, let me do a translation here. If I said something like, it's not impossible. Where P stands for possible, or P stands for it is possible. Now notice. Got two things in there that mean none. Now, when we're translating, don't make the substitution. If you're translating, don't make the substitution. What do I mean by that? If you're taking one of these and I'm saying put it into formal language, just translate it as it is, whether it's well-formed or not. So in other words, how would we translate this? Squiggle, squiggle, P. But the simplest way we could put it? No. But that's why I could give you this argument. I could say, hey, it's not impossible. And someone could say, so it is possible. And I say, hey, prove that's a valid argument. Well, line 1, not P, assumption. Line 2, P, double negation, line 1. That's a valid argument. Well, the other way is also valid. I want to make sure that's clear. So if I say it's possible, someone goes, so you're saying it's not impossible. Yep. How? Double negation. Which is a rule of substitution, which means it can work in either order. If you've got an even number of negations, it doesn't matter how many. As long as it's even, it's the same thing as having none, because basically that cancels out, that cancels out, that cancels out, that cancels out. On the other hand, if you have an odd number of negations, let's say, on du trois, you got 3 negations, what's that the same thing as? It's the same thing as having 1. So if I said instead here, so it's not impossible, so it's impossible. Yeah. Now, I've got 3 up here, but it could be any odd number. 5 of them, 7 of them, 9 of them, 11 of them. It's the same thing as having 1. And also vice versa. Granted, why you'd ever want to go from this to this, I don't know. And that's because, look, those cancel out, those cancel out, those cancel out, those cancel out, those cancel out. We're left with 1. So that's the way that double negation works, this rule of substitution. Be mindful of it, but don't infer it. Don't skip a step when you're translating. When you're translating any problems that I give you like this, make sure you translate them literally. If there's a not there, make sure therefore you have a tilde in the translation.